0.12 moles of argon gas is admitted to an evacuated 60 cubic centimeter container at 20 degrees Celsius. The gas then undergoes an isothermal expansion to a volume of 500 cubic centimeters. What is the final pressure of the gas? So we'll be dealing with an ideal gas again. So the ideal gas law is PV equals nRT. They tell us N is 0.12 moles of argon. They tell us that the initial volume is 60 cubic centimeters, and they tell us the final volume is equal to 500 cubic centimeters. They give us the temperature and tell us it's an isothermal situation. So since it's an isothermal process, the final and pressure temperatures will be the same. So we have 20 degrees Celsius, and into Kelvin is 293 Kelvin. All right, and then they say, what is the final pressure of the gas? So first, let's put the initial and the final volumes into standard units. So we move the decimal place over 6. For an initial volume, we have 0.00006 cubic meters. And for the final, we have 0.123456 cubic meters. All right, now we can plug them in. If we have PV equals nRT, we want the final pressure, so let's divide both sides by volume. So P is equal to nRT over volume. All right, so now that we have pressure isolated, let's go ahead and plug it all in. So pressure is equal to 0.12 moles times the R value, which is 8.314 joules per mole K. And then it's times by the temperature, which we said was 293 Kelvin. And then we're dividing all of that. For the final volume, we'll divide it by the final pressure, we'll divide it by the final volume. Okay, so the final volume is 0.005 cubic meters. So all of this will give us the final pressure. So when this pops out of your calculator, we'll get 584,640 and change. So we have 584,640 pascals, but they want it in ATM. So if you look on the constants page, if you go up to the resources, click on that and go down to constants. If you go to conversion factors, there's a conversion for kilopascals to ATM. So first off, let's change pascals to kilopascals. So we know that in 1 kPa, there are 1,000 pascals, and then they say in 1 ATM, there is 101.3 kPa. So then we plug in all those values, and P now in ATM, because the pascals cancel, kilopascals cancel, and we're left with the units that we want of ATM on top. That leaves us 5.77 ATM, which gives us a rounded value of 5.8 atmospheres.